Wow. All right, we're here recording, going over some review questions for Chapter 3 before our test tomorrow over functions. So we're starting with number 7, which says to use this graph here in Figure 2 to evaluate at f of 2 and f of 0. All right, so let's start by looking at f of 0. We have, f of 2, my apologies. F of 2, that means the x value is 2. Here is the x value of 2, right there. Where is the y value? At 2 as well, so the answer is 2. F of 2 is 2. Now when I do f of 0, when I go to x is 0, where is the function? It's at negative 2 down here, so that means f of 0 is negative 2. Questions on 7 and 8? Questions on 7 and 8. The outcome is the y, correct. So, but the whole thing is what I'll be expecting on the test, Dina. The whole thing. Questions on 7 and 8?
Wait, so that's going to count on the test?
Well, I don't know how it looks exactly on the test. I mean, I do, but I don't, right? No, I'm looking for f of whatever equals the number. I'm sorry, what did you say?
No, like this is what you want to see, like this is the answer?
Yeah.
Not that.
No, this is what you use to get the evaluation. All right, I think I heard number 9 as well from Alyssa. So let's go over number 9. Now, in number 9, this is a piecewise function. And the way that I taught you to do this was to make t-charts for each of your pieces. So x and y t-charts for each of your pieces. The first piece is x plus 1. The second piece is negative 2x minus 3. So, for the first piece, what values for x am I using for x plus 1?
That's greater than negative.
Actually, that's less than negative 2. So what are numbers that are less than negative 2? Negative 3, negative 4. Very good. So let's just say negative 6. We'll get an idea of what's happening. Now, you'll notice I'm going to write negative 2. You see how I wrote negative 2? Should I be plugging that into this part? No. Why not, Giuseppe?
Because it's not or equal to.
Very good. So by doing this, I'm going to break the rule. And so what type of circle will I plot there?
The open.
That'll be an open circle at that point, negative 2, whatever it is. Okay? Going over the review. Whichever piece doesn't have the or equal to, you plug the number in that you're not supposed to, and you use an open circle. Okay, so what's negative 6 plus 1?
Negative 5.
Negative 5 plus 1.
Negative 4.
Great, you get the idea here? So I have an open circle at negative 2, negative 1.
I think I'm gonna have this place.
Okay. Yes, question? No? Okay. All right, are there any questions on the first piece? The first piece, x plus 1. You'll see it's linear, so that's why I drew a line there.
If it's not linear.
Well, if it's not linear, if it's quadratic, it'll be curved. If it's absolute value, you'll have a piece of it, piece of the v. What's up, Diana? Are you confused by something?
Why did you do that circle?
Why did I do that open circle? Because at negative 2, negative 1, it should be open. Okay? The second piece? The second piece, I need values that are greater than or equal to negative 2. It's going to be closed, right? All these will be closed. So I know negative 2 is greater than or equal to negative 2. What about other values? 1, 0, 1, 2. Get the idea? Excellent. So what's negative 2 times negative 2? No.
Negative 4.
4. 4 minus 3 is 1. The y value is 1, Bashir. Excellent.
2 minus 3, negative.
Can we put the keys? Can you put the keys down? So that's going to be 2 minus 3, which is negative 1. 0 minus 3 is negative 3. You can see what's happening with our y values. They're decreasing by the slope of negative 2. So we're going to plot those points. Yes, you will have a calculator tomorrow. No, you will. Yes, question, Giuseppe? Okay. Any questions about number 9?
Wait, so
Yes.
the greater than or equal to is always going to be enclosed?
Correct. So you'll notice at negative 2, negative 1, I have a closed circle right here.
Mhm.
So when you are following the law, it's closed. When you're breaking it, it's open. No, not like that. Everybody okay? Excellent.
Is this the only thing that we do with the
What do you mean?
Just like plot these.
Well, I didn't ask you about domain and range, but if you wanted to, what's the domain of this function?
Wait, so how would we know anything as x?
What would be the domain of this function? What x values could you plug in?
-2, negative.
Oh, it's like negative infinity.
Oh,
Positive.
it is. It's all real numbers.
Like,
I don't know. So we have the arrows are going in both directions forever, right? We have no issues with any x values plugging in. So yeah, it's all real numbers. What about the range? I heard no. What about the range?
wait, is this the domain for both?
Remember, lowest to highest. Good question. Hold on, Diana. What did you say?
Is this the domain for both? Because it doesn't.
You say both, and yet there's only one function here. I know it's your brain sees two, right? But that's two pieces of one function. So I know it's weird that I put them in different colors, but they're the same function. This is one function with different pieces. Say it again? Yeah, that's why it's piecewise, so it's piece. So it's actually negative infinity, not to positive infinity. The highest y value is 1. And it's included, right? See how it's a closed circle? So you have a bracket.
Wait, so domain is x and range is 1?
Yes.
And you go from the lowest.
Lowest to highest. Always.
Why is it a bracket?
Why is it a bracket around 1?
Because it's included.
Because it's included. It's a closed circle at 1. 1 is included. If this was an open circle at this point, then it would be a parentheses.
But why don't we use the other part of the function? Why would we use the orange one?
I'm actually using purple and orange for the lowest y value, but the highest y value is on the orange piece. And again, I don't want you to think they're different functions, right?
Wait, range is y.
Range is 1. What's up? Great. Okay. Okay. Oh, we all feel good about 9? No, we don't, Heidi. No, I'm sorry, I should have made that clear. Somebody just asked about this, domain and range.
I won't be on the. I'm confused
What are you confused about? The fact that I'm playing coy?
about domain and range. Like, if we're gonna need to do that or not, I don't get it.
Okay, what don't you get? Do you understand why it's negative infinity to infinity for the domain? So this arrow is moving this way forever, right? So that means the x values are moving that way forever. This arrow is going like that forever, so it's going to hit all. We're going to hit all the x values. So that's why it's a negative infinity to infinity. Basically, you're saying, hey, plug in anything you want. Now, these inequalities will determine which piece you use, but you can pick any x value and plug it into this function. The y values, though, are different. You can't get all the y values. Both arrows are going down forever, so we're going to hit negative infinity. That's our lowest one. But as you move up in the y direction, your highest y value is 1, right? That's the highest y value. There's no arrows going up.
So if it was going down to be positive infinity?
Yeah, if one of these arrows was going that way, well, then you'd have, your domain of range would be the same.
So for the x, can you put brackets?
If you have infinity, it should always be parentheses. If this had stopped right here, then yes, you would have -7 would have been in a bracket for the lowest x value. Okay? I think if you check your notes in the videos, it's in there. All right? Okay. Everybody good on 9? All right. Yeah, Pablo.
For number 1.
Excellent. So we're going back to number 1.
We do number 3 after doing number 1.
Absolutely. Was there a question, or you just want me to talk about number 1? You just said, like, going back to number 1, and then you stopped talking.
I'm sorry.
It's okay.
I mean, it's like, okay, yesterday when we was doing some of it, we don't want to not know, like, are we supposed to, like, which one can have more than just one?
Can anyone answer Pablo's question?
You can only
We said different things.
you can only have one x.
You can't have more than one. One?
But X,
You can't have
like,
more than one egg.
like the X
Just
value.
because
Mathematically,
Lily said it.
Mathematically, the statement is each input.
Should have one.
Each input should have one.
Yes, but the idea is that you can't repeat inputs. So what Gilberto's brain says is, okay, I can't repeat inputs. That means don't repeat the x.
But your outputs can be.
But your outputs can repeat.
So that is a function.
Well, let's see.
No, because the x repeats.
Yeah.
But they don't have the same output.
Here's what I think helps some students. This helped me when I was in high school learning this. And if this doesn't help you, I'm sorry. But I think the best way to do this is just to plot the points.
Okay.
And really, the question comes down to the 6-1 and the 6-2, because you see how there's a repetition. So if I plot 6-1, do you agree that that is 6-1? 6-1. Yes? So then 6-2 would be right on top of it. And if you do the vertical line test, it fails the vertical line test. So this is not a function. What you would write is, it's not a function because the input of 6 has more than one output. And for a function, each input can only have one output. I believe I wrote that in the answer key. I think I wrote the input of 6 has more than one output, or has two outputs.
It's not a.
This is not a function. This is a relation. Not a function.
They don't have the same.
It's not a function because the input of 6 repeats with a different output. Can't have it. Okay. Number 3. Yes, number 3. Number 3. Maybe this will be a quick thing to see, but those are absolute. That's an absolute value symbol. Yes? Did that help? Was that what the issue was? This is absolute value. So what's 3 times -3? -9. What's -9 minus 1? The absolute value of -10 is 10. 10 times 2 is 20.
Wait, how do you know the active value?
It's
always the active value is like how many points you are away from zero.
Correct. So it doesn't matter what direction you are from 0, just matters how far away you
So
are.
it's basically the opposite number.
I wouldn't say opposite. It's about distance, and distance is neither positive or negative. All right? I always say this every year. I said it when you were a sophomore. I said it when we did this last week or week before. If you drive from your house to here, and you drive from here to your house, you've traveled the same distance. Would you agree? Yes? You haven't gone positive in one direction and negative in the other. It's just the same distance. Distance is neither positive or negative. Okay? Everybody good? Okay, do I need to do the other one, f of 2, or? Well, Diana asked. Do I need to do f of 2? I can. No? There's an f of 2 as well. Do you want me to do that one as well? Okay. F of 2, when you plug that in, see if you get the right answer, Diana. Mr. Ryder. That's all right. You looking for Mr. Mendez? He's in 220. You're welcome.
Answer 10.
For those keeping track at home, there's one.
Over
What's the answer?
10.
6 minus 1. Yeah, that sounds right. 6 minus 1, 5. Absolute value 5 is 5. 5 times 2 is 10. Yeah.
Times 2 is 20. Oh, you're supposed to do both of them?
Yeah, you gotta do both of them. Is that good? Cool.
Yeah. Yeah.
Excellent. What's next? Well, that's a 2 up front. It says 2 times the absolute value of 3x minus 1. It was finished. For f of 2, there were 2 answers. There's f of negative 3, which we got 20, and f of 2, which we got 10. So there's 2 answers. Just the fact that one is half of the other, do you know, is just a coincidence? Is that what's throwing you off? Okay. Who's got another one? 21? I'm feeling... Nope, that's the wrong song.
Oh.
All right. Ooh, this is a really good one. I like this one a lot.
Why?
I wonder why. Okay. We're like gonna leave, and what time do we leave? Lily's got me. It's like 2:01. Okay, we have 15 minutes, so that's fine. All right. 21. Does anyone know what kind of function this is? It's the absolute value function. All right, so the first thing I do is how did I know that? Because it's a V.
So any V is an absolute value.
Boom, truth.
Word.
Okay?
Yeah.
Now, is it at 0, 0? Is the V like this? Is the red one happening? No, that's the parent function. That would be the absolute value of x. So I don't want that. I want the blue one, which is going to be moved. How? How is it moved? To the right. So the right 3 units. So that's going to go inside the absolute value. I need x. Now be careful. To the right 3
It's the opposite.
is minus 3. Here's something you can do to check. This point is what? What is this ordered pair right here? No, what is it? 3 what? 3, 3, 0. So when you plug in 3, you must get 0. 3 minus 3 is 0. What's the absolute value of 0? How do I know how to move it? Because it always moves from the center, from the origin. So in this case, it was moved 3 to the right.
So from whenever it's left to right, it'd be negative, right?
Well, careful. If I had moved it to the left, then left 3, then it would be x plus 3 in the inside.
Yeah, that's be like negative inside.
No, if it's to the left, then it's addition inside. I think what your brain is saying, if it's left or right, Diana, it's inside. But be careful on the direction. If it's up or down, then it would be on the outside. Again, you can check your notes and video that we made a week or 2 ago.
Outside.
Why is it negative 3?
Because from the 0, it goes to the right. So if it's positive, it's like there, it's like negative.
Well, this is ultimately what we're filling in. The horizontal shift goes inside. The reason, Jimena, that it's subtraction is because we moved 3 units to the right, which is a positive 3. So plugging in a positive 3 there continues to be subtraction. Does it move up or down?
No.
No, so my k is nothing. But if I had moved it up or down, then the k would be a different number, like plus something or minus something. I was just showing you a way to check. That's 3, 0. So when you plug this in, you better get 3, 0. 3 minus 3 is 0. Absolute value of 0 is 0. Questions on 21? Okay, what's next? I think I heard, Natalie, you said one? 6. Student, go for it. Okay. Number 6. So to determine whether it is a function, you use the vertical line test. So does 6 pass the vertical line test?
Yes.
Yes. Does anyone know, for bonus points, what kind of function that is?
Infinite.
No, we'll get there. Like the name of the function.
Oh man, you said
I did actually say this one. Yeah. The question is, you just said that number 6 is a function, which means it has a name.
It's not.
Like linear, quadratic, cubic, absolute value. It's none of those. Sad. You don't know it, you would have said it. Starts with an R.
Irrational.
It is rational. Now you're going to think that you knew that, but that's cheating. All right? The rational function. All right, and I showed you guys that when we did this a couple weeks ago, that whenever you get closer and closer to these axes without touching, those are called asymptotes. Asymptotes. Vertical asymptotes, horizontal asymptotes. Those words should sound familiar. We've discussed them in class before. Not necessarily in our class, but in other classes. All right? Now, that's not ultimately what is happening here. We know it's a function. The question is now, is it also one-to-one? How do we check one-to-one? The horizontal line test. And you'll notice this also passes the horizontal line test. So this is also one-to-one. One-to-one means that each input has exactly one output and there's no repeats of the outputs. Like every input has a unique output. Like, do you see here? Look at 4. This is a function. Does anyone know what kind of function number 4 is? It's not quadratic. It's a cubic function. But we repeat y values. Do you see how the y value of 0 is repeated 3 times? So that means not every input has a unique output. The input of -2, 0, and 2 have the same output. So it's a function, but it's not one-to-one. One-to-one is just basically saying, how do I say this? Do you know, like when you learn about shapes? Like think back to when you were really little, and you learn about shapes, right? If you saw a 4-sided shape, what could you call a 4-sided shape? Even more than that, 4 sides means quadrilateral. 4 sides is quadrilateral. To get from quadrilateral to rectangle, you have to have parallel sides, right? And you need 90-degree angles. So what's crazy is that when students see this, they think rectangle. Yes? You should, but it's not a square. It's also a quadrilateral. We just don't say that anymore because the most specific way to define that shape is rectangle. But like when I show my daughter this, I teach her that it's not only a rectangle, it's also these other things. But we call it a rectangle because that's the most specific, right? Human, man, Mr. Vrandrick. You don't call me human or man. Sometimes you call me Mr., right? But you're supposed to call people by their names because that's specific to them. Okay? Does that kind of make sense of why we say one-to-one? All right. Well, I wanted to make sure she was back for that. For the one-to-one is we're saying, like, is it a special function? This function, the rational function, is a special function. It's a one-to-one function. Not every function is one-to-one. To hear the learning. All right, let's try another one. Who's got another one? 23? Wait, do you have one, Lily? 23 as well. What, 7? 7. My bad, all right, time. 17. Just talk about them. Let me do 23, and I'll come back to 17. Okay? And then I think we'll be done.
We need to know the teacher.
There will be vocab on the test.
How many?
Not all of them. Are you trying to decide if it's worth reading or not?
It is not necessary.
You cannot pass by getting all of them wrong. How about that?
How many can I get?
Amazing. So, number 23. says to do f of g of x and g of f of x. All right, this is called what? Oh, sad. Well, we're going to determine if they're inverse functions by using something. What I just wrote in blue is called something. Man, this is sad, guys. It's really sad. Putting one function into another.
Transformation. Proposition.
There you go. You got it.
Oh, I didn't even see that.
I know you didn't. Composition.
Yes, we did
All right.
that.
Did you though?
Yes.
All right. So you're going to write f of x first, which is box cubed minus 5.
Whoa, wait, why did you do?
I wrote the first letter first, f of x. So you should see x cubed minus 5, but where it says x, I replace with a box. Because I'm going to put what function in there? The g of x. So in parentheses, I'm going to put the cube root of x plus 5. Now what happens when you cube a cube root? Those are inverse functions, or excuse me, not functions. Those are inverse operations, so they're going to become, they'll go away and leave you with just x plus 5 minus 5, which is equal to x. Now, if you get x,
Then you can continue.
that means you continue and do the other one. So we have the cube root of box plus 5. Okay, spoiler alert. So I'm going to put in x cubed minus 5. You'll notice there's nothing being multiplied there. So if you subtract 5 and negative 5 here, or add them, excuse me, negative 5 plus 5 is 0. You get the cube root of x cubed. And what is the cube root of x cubed?
It takes out the cube.
So it's just x. All right?
Wait, and what? How'd you do that?
How did I do that?
5 plus 5.
See how there's nothing in front here? So I don't need to worry about like multiplying anything. So imagine the box and the parentheses are gone. So now negative 5 plus 5 is 0. So I just have the cube root of x cubed. Now we're not finished yet. Whoever was asking about this. There you go. You finished it.
So, I did it as the cube root first, and then cross that out, and then negative 5 plus 5.
Can't do that, right? You have to simplify in the radical first. All right? And then Lily said the answer. The answer is, since these are both x, these functions are inverses of each other. So I think on the key I wrote f of x and g of x are inverses of each other.
So they have to equal that.
Well, again, as I told you, they have to equal whatever is here, do you know? So if this had been f of g of 5, then they better be 5 for both. And you would do g of f of 5. Better be 5. All right, we're going to go to 17, I think. Okay. 17, and this will be it. Then we'll move the desk back.
Which one are we doing? All the others.
Let's do 17.
Videos from other classes?
I can, yeah.
Yeah, can you do that, please?
Okay.
It's not covering all.
Correct, but what if they pick the same problems? Okay.
Maybe you show them a better way. You don't know.
Yeah, I save all the good stuff for the other class.
Yeah.
I do.
A different way. You teach
I usually prefer the students who call me Mr. Vrandrick.
Mister. Why are you so
Couldn't even do it. Okay. What kind of function?
cute? Quadratic.
Quadratic. So when I sketch this, it better look like a what? A parabola. Now it doesn't say x squared. It says parentheses x minus 3 squared. And you should notice that this is similar to that absolute value one. It's in the parentheses minus 3, so it's 3 to the right. That's it. Yes, is that okay, honey? Let's keep going. 18. What kind of function is 18? The square root function. Do you remember what that looks like? Squiggly, that's helpful. So it's like a parabola that's on its side, but it's only that piece, only half of it. Giuseppe's right. All right? And the plus 5 is where? Outside. So it's going to move up 5. So it starts here and makes its way over there. So that's 5 up. Yep, square root of x is always going to look something like that.
Oh, cube.
Okay, wow, there's a cube. Now, do you remember what the cube looks like if this was just x cubed? Not squiggly, it looks like this. And you see how it kind of like flattens out somewhat at 0, 0? We're going to talk on Friday about that being a triple root. All right, so that's a triple root. That's why you have a cube that's called triple roots at 0. On my key, I think I put like something like this. Technically, that is incorrect. I just wanted to show you that there were 3 of them. 1, 2, 3.
Wait, so the answer is?
The answer is going to be from this. Do you see this negative that's in front? All right, that negative is going to take it from looking where it's like this. Sorry, I guess I should put it like this to look like that. So let me show you. Okay.
So that's negative.
This negative in front causes it to reflect, and so it moves these to open in different directions. This is the answer here. I'll box it. That's the answer.
So when it's positive, it is negative.
Correct. Positive like that. I drew this on the key. Technically, that's wrong, but I want to show you 3 of them. Okay, let's do what last one? Pink. Now, do you guys see how we have multiple shifts happening? What would you say those shifts are? 2 to the no, to the left, and 1 down. The minus 1 is down. So 2 to the left and 1 down is here. And then Giuseppe sees this negative, which causes it to open down. So it's a parabola opening down. Go ahead and move the desks back. We have 1 minute. I'll post this video, and I'll also record my other class period and post that as well. Thank you for listening. Thank you for watching. Like and subscribe. Good luck tomorrow. No!